When you open an app and the dashboard loads instantly, you're experiencing a highly engineered illusion. That seamless speed often hides a deep structural vulnerability. Modern system performance relies on a simple priority. Doing less work is always superior to doing work faster. To avoid unnecessary work, engineers use a shortcut called caching. Instead of asking the database to compute the same complex math a million times a second, the system calculates it once, stores the result in a temporary memory bank, and serves that pre-computed answer to everyone else. While this feels like an engineering superpower, it introduces a dangerous vulnerability. By creating a temporary copy of that data, you have secretly cloned your application's reality. Left, your database, the reliable truth. Right, the cache, a volatile clone. When an update occurs, the database registers the change, but the cache remains ignorant, trapped in the past. The truth lives in the database, while users are fed a rapidly replicating lie. If a server crashes, you get error codes and loud alarms, but this failure is totally silent. The system appears healthy. CPU usage is fine. It simply operates perfectly while delivering corrupted data to millions of screens. A system lacking a mechanism to forcefully synchronize these two realities is actively deceitful. Fixing this silent split requires a technique known as cache invalidation. We usually think of databases as tools for remembering things, but invalidation requires a different mindset. It is the active, deliberate process of knowing precisely when a piece of data becomes wrong and destroying it. When you get this timing wrong, users see outdated task statuses, overdrawn bank balances, and ghost inventory that doesn't actually exist in the warehouse. Mastering the precise execution of forgetting is the hallmark of senior-level system design. This chart shows the strict trade-offs engineers face, balancing simplicity, accuracy, and speed. Our first weapon is time to live, or TTL. Data simply expires on a countdown timer. As you can see, it maxes out on simplicity and speed, but its accuracy score completely collapses. That low accuracy is a mathematical guarantee. Until the timer expires, the system will serve lies to the user, even if the real data changed minutes ago. Strategy 2 is the write-through method. This forces the cache to update the exact moment the database changes. Accuracy hits 100%, but simplicity vanishes as a massive new complexity metric spikes off the chart. Keeping those writes perfectly synchronized across servers creates a heavy, tangled web of dependencies. It preserves the truth, but the sheer complexity makes it difficult to scale. Most modern platforms use the industry standard, cache aside. Here, the system checks the cache, falls back to the database if the data is missing, and then updates the cache itself. This balances speed and truth, but it still requires deep, custom invalidation logic to prevent stale data from looping indefinitely. There is no perfect method, only strategic trade-offs between absolute correctness and system velocity. In the era of AI-assisted development, these trade-offs are often ignored. Rapid code generation creates massive applications while hiding structural vulnerabilities deep in the foundation. AI coding tools eagerly generate caching layers to make your application feel artificially snappy and responsive. The ultimate trap is that AI almost always ignores the logic of cache invalidation. It builds systems with total amnesia, holding onto lies forever. This creates a spaghetti architecture of silent bugs. These errors never trigger a server crash, but they slowly corrupt the user experience as the system serves outdated facts. While some duplication is necessary for speed, the back-end domain layer must ruthlessly enforce data ownership. One source must remain the final authority. Blindly accepting AI-generated speed without enforcing a strict source of truth will inevitably cause your architecture to collapse under its own contradictions. Building a resilient system requires a fundamental shift in how we view performance optimization. We have to remember the golden rule. A cache is a temporary performance hack. It must never be treated as the authoritative source of truth. Builders should separate data by criticality. Trivial information can expire on a simple timer, but essential facts require aggressive, forced synchronization. To build truly resilient, scalable systems, you must engineer the exact moment your architecture should let go of its data.